All right, in this function, in this video, we're gonna talk a little bit about function notation and what it looks like on a graph. I'm not going to do any comparison of the two functions to each other. That will be in a different video. I just kind of want to give some reasoning behind the notation and why it is what it is. So let's say, for example, you're looking at the f function. So you've got the function f of x, all right? That's this black curve down here. So this function has infinitely many points on it. If you wanted to find one of the points on this function, maybe you would say something like f of 1 equals 0. So what that says is when the input on function f is 1, the output is 0. And I got that answer from this coordinate point right here. So x is 1, y is 0. What if instead I wanted g of 1? So that means I now want the input of 1 on the g function. So now I'm looking at a different function. So it could have the same output. It could have a different output. It could have a related output. It could have a non-related output. So in this scenario, when I plug in 1 to the g function, I get out 2. So when x is 1, y is 2. Notice, if we just said x and y, it would be confusing as to which function we were talking about. So when we have a point on the black curve, we could say those coordinates are x comma f of x. So x is the input of the function, and f of x is the output of the function. F of x is what I get when I plug in the input. And then for my red, I could have points that are x comma g of x. When we compare the two functions, which is what we're going to do moving forward, we're looking at how the values of the function are different at the same x. Similar to when we said in the table, we kind of keep a table consistent. In general, when we're studying functions, we look at the value of the function, which is the output or the y value, compared to similar x values.